For over 4 decades, the M1 Abrams has served as the backbone of American armored forces, dominating battlefields from the deserts of Iraq to the mountains of Afghanistan. Since its introduction in 1980, the Abrams has undergone continuous evolution, with variants like the M1A1 and M1A2 incorporating incremental improvements in armor, firepower, and electronics. However, by the early 2020s, it became clear that incremental upgrades were no longer sufficient to meet the challenges of modern warfare. The result is the M1E3 Abrams, a revolutionary redesign that represents the most significant transformation of the Abrams platform since its inception, promising to keep American armor competitive well into the 2040s and beyond. The M1E3 program emerged from a recognition that the nature of armored warfare was changing fundamentally. The M1A2 SEPv3, the latest operational variant before the M1E3, was an incredibly capable tank, featuring third-generation thermal sights, improved armor packages, advanced communication systems, and the Trophy Active Protection System. Yet despite these impressive capabilities, the SEPv3 struggled with several critical limitations. The tank had grown progressively heavier with each upgrade, reaching nearly 73 tons in combat configuration, which strained the original power plant and suspension systems. The interior space was crammed with electronics and equipment added over decades of modifications, leaving little room for future upgrades. Most critically, the basic architecture of the tank, designed in the 1970s, was reaching the limits of its adaptability. The threats facing modern tanks had also evolved dramatically. Precision-guided munitions, loitering drones, top-attack missiles, and advanced anti-tank guided weapons proliferated globally. Peer adversaries like Russia and China developed tanks incorporating active protection systems, unmanned turrets, and advanced networking capabilities. The electromagnetic spectrum became as important as physical armor, with electronic warfare, cyber threats, and the need for constant network communication creating new vulnerabilities. Urban warfare and complex terrain operations became the norm rather than the exception, demanding greater situational awareness and versatility than the SEPv3 could provide. In response to these challenges, the U.S. Army launched the M1E3 program with an ambitious goal: create a tank that retained the proven strengths of the Abrams while fundamentally reimagining its design for 21st century warfare. The E3 designation, standing for Engineering, Evolution, and Enhancement, signaled that this would be more than another incremental upgrade. The program aimed to reduce weight while improving protection, increase automotive performance while reducing fuel consumption, enhance lethality while minimizing crew workload, and create a platform adaptable enough to integrate technologies that don't yet exist. Revolutionary design changes and weight reduction. The most immediately striking difference between the M1E3 and its predecessors is the dramatic weight reduction. Through a combination of advanced materials, redesigned components, and elimination of legacy systems, the M1E3 achieves a combat weight of approximately 60 tons, roughly 13 tons lighter than a fully equipped M1A2 SEPv3. This weight reduction wasn't accomplished by sacrificing protection. Rather, it represents a fundamental rethinking of how armor and survivability work in modern combat. The hull and turret structure incorporate extensive use of advanced composite materials, including carbon fiber reinforced polymers and new generation ceramics that provide equivalent or superior protection at a fraction of the weight of traditional steel armor. The M1E3 features a modular armor system that can be rapidly reconfigured based on the threat environment, allowing commanders to optimize the tank's protection-to-weight ratio for specific missions. The suspension system received a complete overhaul, replacing the M1A2's torsion bar suspension with an advanced hydropneumatic system. This new suspension provides superior cross-country mobility and crew comfort, allows the tank to adjust its ride height and hull attitude, and reduces the overall weight of the suspension components. The ability to kneel or raise the hull independently at each corner improves the tank's ability to take hull-down positions and engage targets from defilade. Perhaps the most controversial change is the reduction in crew size from 4 to 3. The M1E3 eliminates the loader position, incorporating an autoloader system into the redesigned turret. This decision was not made lightly, as the U.S. Army had historically resisted autoloaders, citing concerns about reliability and the value of having a fourth crew member. However, advances in autoloader technology made this change inevitable. The M1E3's autoloader is capable of handling multiple ammunition types, achieving a rate of fire comparable to or exceeding that of a human loader. The reduced crew size also means less internal volume needed for crew stations, allowing for better armor distribution and reducing the tank's overall profile. Enhanced firepower and ammunition systems. While the M1E3 retains the 120mm smoothbore main gun that has served the Abrams family since the M1A1, virtually everything about how that gun functions has been upgraded. The M1E3's main gun features an extended barrel, a more advanced recoil system, and compatibility with the latest generation of ammunition including programmable airburst rounds, extended-range kinetic energy penetrators, and advanced multipurpose rounds. The autoloader system represents a quantum leap in ammunition handling. It can store up to 42 rounds of main gun ammunition in an armored bustle magazine, isolated from the crew compartment by blast doors. This arrangement dramatically improves crew survivability compared to the M1A2 system, where ammunition is stored both in the turret bustle and in the hull beside the driver. The autoloader can select and load any type of ammunition in the magazine within 6 seconds. The fire control system itself is revolutionary, incorporating artificial intelligence and machine learning algorithms that can identify, classify, and prioritize targets faster than any human crew. The system integrates data from multiple sensors including thermal images, daylight cameras, laser rangefinders, and networked information from other friendly units. The commander and gunner each have independent panoramic sights with 360-degree coverage, allowing the commander to search for new targets while the gunner engages the current one. If you're fascinated by cutting-edge military technology, please hit that like button and subscribe for more in-depth defense analysis. The M1E3 also incorporates directed energy weapons for the first time on an American main battle tank. A high-energy laser system mounted coaxially with the main gun provides the crew with the capability to engage drones, incoming missiles, light vehicles, and personnel at ranges up to several kilometers. This laser system provides effectively unlimited ammunition as long as the tank has fuel to run its generators. The laser is particularly valuable against the swarms of small drones that have become ubiquitous on modern battlefields. Power and mobility revolution. One of the M1E3's most significant advances lies under the hood. The M1E3 replaces the gas turbine with an advanced hybrid electric propulsion system that combines a compact diesel engine with electric motors and high-capacity batteries. This hybrid system provides numerous advantages. Fuel consumption is reduced by approximately 30 to 40%, dramatically extending the tank's operational range. The diesel engine produces significantly less heat than the gas turbine, reducing the tank's thermal signature. The electric motors provide instant torque, giving the M1E3 acceleration comparable to the gas turbine Abrams while allowing for silent watch mode, where the tank can operate all its sensors and systems on battery power alone without running the engine. The hybrid system also generates substantially more electrical power than previous Abrams variants, essential for operating the tank's advanced electronics, active protection systems, and directed energy weapons. The M1E3 can generate up to 100 kilowatts of exportable power, allowing it to function as a mobile power station for other systems. Maximum road speed increases to approximately 50 miles per hour, and cross-country mobility improves dramatically thanks to the weight reduction, advanced suspension, and superior power-to-weight ratio of around 24 horsepower per ton, double that of the M1A2 SEPv3. This enhanced mobility is crucial for rapid deployment, tactical repositioning, and exploiting breakthroughs in offensive operations. Active protection and survivability systems. Survivability was reimagined from the ground up in the M1E3 design. While the M1A2 SEPv3 incorporated the Trophy Active Protection System as an add-on, the M1E3 integrates a next-generation active protection system as a core component of its design. This advanced APS uses a combination of radar, electro-optical sensors, and electronic warfare systems to detect incoming threats at greater ranges and engage them with both hard-kill and soft-kill countermeasures. The hard-kill system fires projectiles that intercept and destroy incoming missiles and rockets before they reach the tank, effective against top-attack weapons, tandem-charge warheads, and even kinetic energy penetrators at close range. The soft-kill system uses multispectral smoke, flares, jamming, and laser dazzlers to confuse or disable the guidance systems of incoming threats. The M1E3's armor scheme represents a departure from the M1A2's approach. The M1E3 reportedly uses advanced composite armors incorporating new materials such as graphene-enhanced ceramics, reactive armor elements that can defeat multiple hits, and electric armor systems that use high-voltage pulses to disrupt shape-charge jets. The modular nature of the armor allows damaged sections to be replaced in the field. Crew survivability receives particular attention. The three-person crew sits in armored capsules designed to protect them from catastrophic ammunition detonations. Advanced fire suppression systems activate faster than those in the M1A2, and improved ventilation and climate control reduce crew fatigue. Each crew member has their own independent escape hatch. Network-centric warfare and situational awareness. Perhaps the most transformative aspect of the M1E3 is its role as a network node in a larger combat system. The tank features advanced communication systems that allow it to share real-time data with other friendly units, from infantry squads to aircraft to artillery batteries. This networking capability transforms how the M1E3 fights, allowing it to engage targets it cannot directly see based on information from other sensors. The crew stations feature advanced digital displays that replace the traditional analog gauges and periscopes of earlier Abrams variants. Large touchscreens provide intuitive interfaces, and augmented reality overlays superimpose tactical information onto the crew's view of the battlefield. The commander and gunner can access feeds from drones, satellites, and other sensors, dramatically expanding their awareness. The M1E3 is designed to control and coordinate with unmanned systems, serving as a command node for robotic vehicles and drones. The tank can launch, recover, and control small reconnaissance drones directly. It can also network with larger unmanned ground vehicles, using them as scouts, mine rollers, or remote weapons platforms. Operational flexibility and challenges. The M1E3 is designed for a broader range of missions than its predecessors. The modular design philosophy extends beyond armor to include mission packages that can be installed to configure the tank for specific roles. A standard combat configuration optimizes the tank for high-intensity warfare. An urban warfare package adds additional cameras, non-lethal weapons, and enhanced communication systems. A reconnaissance configuration reduces armor for maximum mobility and adds enhanced sensors. Despite its impressive capabilities, the M1E3 faces several challenges. The program has experienced cost overruns and schedule delays. Each M1E3 is significantly more expensive than an M1A2 SEPv3. The advanced systems require extensive crew training, and maintenance demands specialized skills. The decision to adopt an autoloader and reduce crew size remains controversial among some tankers. The reliance on networked systems creates vulnerabilities to electronic warfare and cyber attacks. Strategic implications and global context. The M1E3 represents a shift in how the U.S. Army thinks about armored warfare. The emphasis on networking and information sharing reflects a recognition that future battles will be won by superior integration of all combat systems. The tank's ability to control unmanned systems points toward a future where manned tanks work alongside robotic vehicles. The weight reduction and improved fuel efficiency address strategic mobility challenges. Lighter tanks are easier to transport by air, sea, and rail. Better fuel economy reduces the logistical tail required to support armored operations. If you're enjoying this detailed analysis of the future of armored warfare, don't forget to like and subscribe for more military technology content. The M1E3 emerges at a time when other nations are also developing next-generation tanks. Russia's T-14 Armata features an unmanned turret design. China's Type 99A continues to evolve. Germany and France are collaborating on the main ground combat system. The M1E3 distinguishes itself through its emphasis on networking, modularity, and integration with unmanned systems rather than simply pursuing maximum armor or firepower. The future of the Abrams legacy. The M1E3 Abrams represents both continuity and revolution. It retains the basic mission and many of the core strengths of the original M1 Abrams while fundamentally reimagining how a tank operates in modern warfare. The program demonstrates that even a platform designed in the 1970s can remain relevant through bold redesign rather than incremental upgrades. As the M1E3 begins to enter service, it will face the ultimate test, actual combat operations. Only battlefield experience will reveal whether the design decisions made during development were correct, whether the new systems are reliable under combat stress, and whether the capabilities justify the cost. The Army plans to procure the M1E3 in substantial numbers over the coming decades, eventually replacing most or all of the existing M1A2 fleet. The tank's modular design and substantial electrical power generation capacity should allow it to remain relevant for decades by incorporating new technologies as they become available. Future upgrades might include more powerful directed energy weapons, artificial intelligence systems that further reduce crew workload, enhanced autonomous capabilities, or technologies we haven't yet imagined. The M1E3's architecture is specifically designed to accommodate such evolution, learning from the limitations of the M1A2 platform. The M1E3 Abrams ultimately represents a bet on the continued relevance of heavy armor in an era when some analysts have questioned whether tanks have a future on battlefields dominated by drones, missiles, and precision-guided munitions. The tank's designers believe that properly designed and employed, heavy armor remains essential for breaking through enemy defenses, holding ground, and providing mobile, protected firepower that lighter systems cannot match. The M1E3 aims to prove that armor can adapt to meet modern threats while retaining the fundamental advantages that have made tanks central to ground warfare for over a century. Whether this vision proves correct will shape the future of armored warfare for generations to come.